Exponential and logarithmic equations. We start with the basic formulas. Base to the power exponent equals argument. To explain more about this, as an example, 10 to the power 2 equals 100. So 10 is called the base, 2 is called the exponent, and 100 will be the argument. Writing the whole thing as a logarithmic form, we start with log of the argument, base goes down, and the output will be exponent. So writing this in a different way, it's right here. Log 100 base 10 equals 2. And one way to look at this is when we say 10 to the power 2 equals 100. It's called the triangle of power. It's on M3 172 in your textbook. A and B and C, as you could see in the triangle, and we kind of go this way. A to the power C equals B. Or we could rewrite it this way. Log B base A equals C. And we could double check always by looking at it this way. A to the power C equals B. A to the power C equals B. Let's try some examples to change from exponential form to logarithmic form. On the left, I have 12 to the power 2 equals 144. To write this as a logarithmic form, we're gonna write it this way. So we start with log. The base is 12, so we write 12, and we leave some space here. If you want to read it as a power, 12 to the power 2 equals the argument which is inside 144. Let's go backwards from log 4 base 16 equals half. To write this, we write 16, which is the base, to the power half, that means square root, equals the argument which is 4. The third one is going from 10 to the power 3 equals 1000, writing it as a log. So we start with log, the base is 10, and the exponent is 3. 10 to the power 3 equals 1000. Whenever you see len on the last step, that means it's the same thing as len is equivalent to log base e. So keep that in mind. So let's write this as exponent. So this is an e, but it's not written. E to the power 3, e to the power 3 equals, or approximate to, because it's not 100% equal, 20.086. That should do it for this table. Here's an example. It's the same problem. We know one thing, that 4, if you want to keep this for this problem because it keeps repeating, and it's 4 times 4 times 4, or 4 to the third is 64. Just keep this in mind for number 1, 2, 3 in this problem. 4 times 4 is 16, 16 times 4 is 64. So how could we solve this problem? To solve for y, let's write it as a power. 4, this means 4 to the power 3 equals y. And when you multiply 4 times 4, that's 16, times 4, that's going to give you 64. So 4 to the power 3, we replace this with 64. So therefore y is 64. That should do it for number 1. Number 2, the exponent is unknown. the exponent, which is x right here, is unknown. It's the same problem as I said. Look, 4 to the power 3 equals 64. Same thing. We're looking at it from the three pieces. This time the exponent is unknown. So here we go. 4 to the power x equals 64. But we know that 64 comes from 4 times 4 times 4. So I could say 4 to the power x on the left, leave it as is. Right hand side, it's a 4 to the power 3. Comparing the exponents, since the bases are the same, we end up with that x should equal to 3. So x equals 3 and we are done. Third problem. Base is unknown. B is unknown, but we know how we could read this. B to the power 3 equals 64. B to the power 3 equals 64. What number do you multiply by itself 3 times and you get 64? That should be 4. 4 times 4 times 4 is 64. So B should be 4, and that should do it. B has to be 4. Next, some properties about logarithms, which is in M3 187. The first one is simple. Log 1 base b equals 0. Why? We're not going to explain the other ones like 3 and 4 and 5, but we're going to use them. If you write this as a power, we have b to the power 0 equals 1, and we know that any number raised to the power 0 is 1. Second property, it says log b base b is 1. Let's give it a try and read it as a power. b to the power 1 equals b inside, which is true. Now the third one says log the product. This is a product. Then you take log of both sides, or 2 times, with an addition. Now you change it to addition, and after that this is a quotient, changes to subtraction. The last one, if you have an exponent, you kind of move it up front and becomes right there in the front. Let's practice. 2.2, using properties of logarithms to rewrite expressions on M3 191. Use the properties of logarithms to rewrite each logarithmic expression in expanded form. So we're going to expand it, make it longer, just like those rules. See, the right hand side is longer than the left hand side, especially on rule number 3 and 4 and 5. So let's write this in an expanded form. First of all, we need to notice that we have a product, which is right there, and it's not shown. This is a product. So we're going to change the product to addition, just like rule number 3. All right, here we go. So that's going to equal to log base 4 of 6 plus, we change it to addition, log x to the power 5 base 4. Then rule number 5 says if you have an exponent as x to the power a, we bring the a up front. So we're going to bring this a up front. This is my a. We're going to have to move it up front. So this becomes log 6 base 4 plus 5 is going to go up front, log x base 4, and that should do it. Next example, log base 7 of 3y to the 4 over x cubed. So we have a fraction, we have a product, and a power. So three things. We're going to use rule number 3 and 4 and 5. Let's focus mainly on this quotient right here. This quotient is going to change it to subtraction. So here we go. Log base 7 3y to the 4 minus log base 7 x cubed. Now we have a product right here between 3 and y to the 4. We're going to apply the product rule, which is rule number 3. So this is log base 7 of 3. Product changes to addition. Log y to the 4 of base 7. Same base. We keep the same base. Finally, we rewrite the subtraction just down. Subtract log base 7 of x to the 3rd. Now we have the power rule, so we're going to apply it at the same time. This 4 here is going to go up front. This 3 here is going to go up front. And we'll finish the problem. Log 3 base 7 plus 4 log y base 7 minus 3 log x base 7. And that should do it. That's called expanded form. We're done. One more example. Ln 3x y to the 3rd. We have a product, as you could see, 3 times x times y, and to the power 3, that's a power rule. So we have two formulas. But keep in mind that ln is the same thing as log, but base e. Instead of writing on the calculator keys for log base e, we just write in short ln. So ln and log are the same thing. Ln, we're going to go 3 because this one is a product. This is a product. And we have another product right here. We're going to change them to addition. So we have plus ln x plus ln y to the 3rd. Then this 3 has to go up front and we'll finish the problem. Equals ln 3 plus ln x plus 3 ln y, and we're done. Next, use the properties of logarithms to rewrite each logarithmic expression as a single logarithm. So this is the other way around. We have expanded form. We're going to take it back to one term. Now, since we have addition right here, that comes from multiplication. And since also we have a 3 up front here, that could go back inside, right here. So let's take care of the 3 first. Let's take care of the 3. So we have log 10 base 2 plus log x base 2, but the 3 I want to put it back in as an exponent, so it's a 3. Now since we have a addition, that comes from a product rule. So we're going to write this as log 10 multiplied by x cubed. as one piece. In a cleaner look, log 10x cubed. And we're done. Another problem. 4 log 12 minus 4 log 2. Let's take this 4 back, and let's take this 4 back. So we have log 12 to the power 4 minus log 2 to the power 4. This is a subtraction, and that comes from the quotient rule, and we write this as the following: log become division 12 to the power 4 over 2 to the power 4, which is the same thing as log 12 over 2, and we take the 4 back. If you remember rules, we have a to the power, or 8 over b to the power m. It's the same thing as a to the m over b to the m. So that looks like this, and that looks like this. So we kind of like took it backwards, took it back as one exponent. Now inside we have 12 over 2, which is 6. So we have log 6 to the power 4. 6 times 6 times 6, and that should give me the answer. One, 2, 9, 6. Okay, 1296. Next problem. Let's rewrite this as a single form. Let's work inside right here, change subtraction to division, and this right here is len 9 to be fixed. And now we have this. Change it from subtraction to fraction, change subtraction to fraction, equals 3. Just keep them the same size, and let's work inside. This is len 3 over x, and this is len x over 9. Let's take the 3 back in, this 3 as an exponent. So this becomes len 3 over x to the power 3 plus len x over 9. Addition, we'll take it back to a product. So we have len, and here let's make it a product. Maybe that's too thick. We'll do this right here as a product, and we'll make it this way. We have 3 over x to the power 3. We have x over 9. This is going to be our last problem, so let's slow down and finish it. Equals len 3 times 3 times 3 over x times x times x multiplied by x over 9. Just one way to look at it, to simplify. I could see that 3 times 3 is 9, cancels this 9, and I could see that this x cancels one of these x's, and we end up with len 3 over x to the second, and we're done. That's it. That should do it, and that should help you with the coming assignments. Thank you.